Find the annual amount, A. In this problem, at time equal to 0, a present value cash flow, P, of negative $10,000 is deposited into an account. The account has an annual interest rate of 5%, and the initial deposit plus interest will be paid back in even increments over the following 10 years. At the end of the 10th year, all the funds, both principal and interest, will be paid back. The question asks to find the annual amount A, which is a constant amount of money paid back at the end of each of the 10 years. This constant amount of money paid back at each period is called a uniform series of payment. This means at the end of the first compounding period, $A will be paid back. At the end of the second compounding period, another $A will be paid back, and so on. To simplify the diagram, we'll add a line across the top of each arrow with the label A. The annual amount paid back each period equals -1 times the present value or present worth of the initial deposit times a discount factor. This particular discount factor is called the capital recovery factor because it converts a present value, P, to an annual amount, A, for a given interest rate, I, and over a number of years, or periods, N. Also notice there is the negative sign because we know P is a negative cash flow and A is a positive cash flow. We can compute the discount factor by using a formula based on variables I and N. For this problem, I equals 5% and N equals 10 for 10 years, or 10 compounding periods. This makes the discount factor equal to 0.1295. This same discount factor can be looked up in a table of discount factors in most any engineering economics book. First, find the page of values for the rate of 5%. Next, the column for A given P, or A/P, the capital recovery factor. Then trace down to the row where N equals 10, and the value at that row-column intersection should be the same as the value we calculated, 0.1295. Next, we'll return to our equation for the annual amount, plug in the present worth and discount factor, and the annual amount paid back each year equals $1,295. When reviewing the possible solutions, the answer is B.